Jupiter doesn't have a solid surface. There's no ground beneath those clouds, nothing you could ever stand on. A colossal blanket of atmosphere wraps the entire planet. So, if a giant vacuum could somehow suck away all of Jupiter's air, what would be left behind? First, we need to understand what Jupiter really is. Earth is a rocky world made of stone and metal. Jupiter, on the other hand, is a gas giant, made almost entirely of atmosphere. About 90% of it is hydrogen, and most of the rest is helium. In other words, it's basically a massive hydrogen balloon. Those swirling bands, the storms, even the Great Red Spot, they're all just layers of cloud. Beneath them, there's no solid ground at all. So if you vacuumed away every last cloud, what would remain at the bottom? Now imagine a vacuum as wide as 140,000 kilometers, switching on and pulling Jupiter's atmosphere in. First go the outer layers, white ammonia ice clouds, then the hydrogen sulfide clouds, and finally the hidden layers of water vapor deep below. But a problem appears almost immediately. Jupiter's atmosphere is unimaginably deep, tens of thousands of kilometers. The farther you go down, the higher the pressure rises, reaching millions of times the pressure on Earth's seafloor. At that point, you're not pulling in gas anymore. Hydrogen begins to flow like a liquid. Temperatures climb to thousands of degrees, and the pressure becomes overwhelming. Hydrogen stops behaving like a gas and transforms into a dense metallic fluid, metallic hydrogen. By this point, the vacuum's pipes would melt, and its motor would vaporize in an instant, because by now, it's already a blazing plasma inferno. Still, let's imagine we somehow managed to remove all that atmosphere. What would be left then? Just one thing: Jupiter's core. Scientists believe that core could be a lump of rock or ice several times the mass of Earth, but no one has ever seen it directly. Even NASA's Juno spacecraft couldn't observe the very center. The pressure is simply too intense. Anything that ventured close would be crushed long before it arrived. And here's the key. The moment that core is exposed, Jupiter stops being Jupiter, because the planet's immense structure is held together by that thick, weighty atmosphere. Strip it away, and the internal pressure collapses. The planet would sink under its own gravity, and even the core itself could crumble. In other words, that colossal atmosphere is Jupiter's lifeline. Take it away, and the planet loses its very identity.